Hello, my little mathematicians. Today, I'm going to help you with the distributive property and then factoring out a GCF. So first of all, if we look down at the bottom, this is what most of our problems are going to look like, is like this. And they're going to say, use the distributive property to simplify this, or factor out the GCF to then find the sum. And you're like, why would I do that? Why wouldn't I just add these? Why wouldn't I just add in here and then multiply it? So in order to kind of see why they're having you do this, I'm going to take a step back and let's pretend, because what this is leading you towards is this skill of eventually we're going to have variables with them, and you can't just combine them because each variable is representing something different. So like this variable A is representing the amount of apples, and this variable B is representing the amount of bananas. And I can't just combine these and say, oh, I have 8 apples or I have 8 bananas. I don't have either of those things. Okay. I have 3 apples and 5 bananas. Um, and so this is kind of showing you can't just combine things however you want. You have to do it in a certain way. Okay. What this number out in front is saying is that you have 2 of these groups. Like you can think of this as like a box. You have a box with 3 apples and 5 bananas, and you have 2 identical boxes like that. Okay. Or you have, let's say 7 boxes with 8 apples and 6 bananas and stuff. Okay. So then that'll let you know like the total amount that you have. So what you do is you take this number out in front, and when it's touching the parentheses right here, it's being multiplied by each thing inside. Okay. I'm going to take this 2 and I'm going to do what's called distribute it to both the 3a, and I'm going to distribute the 2 to the 5b. Okay, and then what happens? I'm going to multiply 2 times the 3a, which is 6a, plus I'm also going to multiply the 2 to the 5b, which is 10b. And then how does that work? Well, think about it. If you had 2 boxes with 3 apples and 5 bananas, okay, and then here's another box with 3 apples and 5 bananas, okay, you have a total of 6 apples and 10 bananas. So it's just an easier way than kind of like drawing your picture out, which it wasn't that bad if you have 2 of them, but what if there was like 100 identical boxes or 53 identical boxes? So this just lets you know you take the number out in front and you're multiplying it or distributing it to each number inside. Okay. Other problems you might see, it doesn't matter if it's like a plus or a minus sign, it's the same concept. Okay, so I'm going to take this number out in front and I'm going to distribute it to this first number, 7 times 8a. And then I'm also going to distribute it to the second number. So I'm going to distribute the 7 to the 6b as well. And if there's a plus sign between them, there's a plus sign, bring it down. If there's a minus sign between them, just bring that minus sign down. And then you just simplify. What's 7 times 8a? It's 56a. And then what's 7 times 6b? It's 42b. And I can't combine those because remember, they're not like things. Like this is talking about apples and this is talking about bananas. Okay. Let's go ahead and take a look at the next one. Okay, you have 5 times 4a plus 5 times 2b. Try it yourself first. Okay, pause it. Okay, you unpaused it and now you're back with us. Let's see how you did. First, you distributed that 5 to the 4a, right? Then bring down your plus sign. I'm also going to distribute that 5 to the 2b. So then what'd you get? What was 5 times 4a? Did you get 20a? Plus, what's 5 times 2b? Did you get 10b? Perfect. And hopefully you didn't combine that to 30ab, because remember, those aren't like terms. That's as far as I can go. Okay, now this one, you have 2 times 7 plus 2 times 4. And what's 2 times 7? 14. Plus, what's 2 times 4? 8. If you add those together, what do you get? 22. Now, I agree. This one was silly. You should have just added 7 plus 4 is 11. And then 11 times 2 is 22. I agree. That's the much better way to do it. But we need to know this skill set for when it becomes harder later. with variables, okay? And so that's why we kind of introduced it now. Also, sometimes when you go to type it in, they'll say simplify this, and then you'll be like, it's 22. And then they have all these different boxes for you to fill in. And you're like, I don't understand. Like, the answer is 22. What other things do they need? They wanted to see the in-between steps of how you got there. First, I distributed the 2 to the 7, and I got 14. Then I distributed the 2 to the 4, and I got 8. If it just asks you for the answer for these, sure, just put 22. But I need you to know how to do this skill set, because sometimes it does ask you to like fill in these middle steps to get there. And you're like, why do they waste your time? Because again, in the future, it's going to be things like this where you literally can't combine them in the middle and do this simple math. Okay. And like this would be your final answer. You can't combine it anymore. And that's what it's leading towards. Okay. Also, the other thing I want to point out that's cool about this is the inverse of this is factoring. So it's kind of like the opposite. You're undoing it. Do you notice that this kind of looks like this, right? And so what they're kind of doing is they want to know, like, how did it start? Can you rewrite this as a product, which means you're multiplying something by another sum? So they'll have lots of different sets of directions you'll see, but it's something like rewrite this expression as the product of the GCF and another sum. Anything along those lines, like when you see factor out a GCF or pull out a GCF, rewrite this as a product and a sum, we're going to do what I'm about to show you. Okay, well, first of all, it's going to talk about the GCF. And when we do the GCF, do you remember what to do? Okay, I'm going to draw that little ladder. And what can go into both 8 and 14? 2 can. 2 times what is 8a? 4a. And 2 times what will give you 14b? 7b, right? So 2 times 7 will give you the 14, and then just tack on the b. And then bring down that plus sign. Does 4 and 7 have anything else in common? Mm-mm. And then what's your GCF? Well, just like before, our GCF was 2. Okay, that goes out in front. And then the thing that goes inside the parentheses is right here, this 4a plus 7b. So how you know that you're right is the number out in front has to be the greatest common factor. So if there's anything inside the parentheses that still has a common factor, you didn't pull out the greatest one. Like, keep going with your ladder. And then a nice way to check is when you distribute this out, you should get what you started with. 2 times 4a is 8a. 2 times 7b is 14b. If you were to distribute that out and you get what you started with, you know you're right. That's what they were looking for. Perfect. Okay, and the same thing goes whether it was a plus or a minus sign. So let's try this one. Okay, what can go into 15 and 6? Not 2, but yes, 3 can go into both. Okay, 3 times what is 15a? 5a. Okay, bring down your minus. 3 times what is 6b? 3 times 2. And then bring down your b. Okay, can anything else go into 5 and 2? Nope, so then you're done. This is your GCF. It goes out in front. And remember, you're rewriting it as a product, so you're multiplying the GCF times some sum or difference. If it's a plus sign, it's a sum. If it's a minus sign, then it's a difference. Just bring it down. And then whatever's down at the bottom, that's what goes here inside of your parentheses. Okay? And that's it. How do I check to see if I'm right? Well, distribute it back out. 3 times 5a gives me that 15a. 3 times 2b will give me that 6b. Perfect. I know I'm right. Okay. For this one, what do you see can go into 48 and 56? Okay. Yep. I see they're both even. So yeah, 2 can go in. 2 times what is 48? 24a. And then 2 times what is 56? 28. And then bring down that b. Now, can anything go into both 24 and 28? Yeah, a 4 can. Or some of you saw 2, so then maybe you would have to do another step in addition to your ladder. Okay, 4 times what is 24? 6. And 4 times what is 28? 7. Now, does 6 and 7 have anything in common? No, nothing can go into both 6 and 7 other than 1. So now I multiply these numbers along the side, okay? And if you had like another row, then you would just multiply all the numbers along the side there. Okay, and you have 2 times 4, which is 8. And now down here, you have a 6a and a 7b. Okay, before I box it, double check. Is in the parentheses, is there anything else that can go into 6 and 7? Nope, then that's the perfect like GCF. And then double check you did your math right. 8 times 6 is the 48. 8 times 7b will give me that 56b. Perfect. Okay. Now some of you you're like, wait, I had a shorter letter. That's fine. If when you did this, 48a plus 56b, if you saw right off the bat that 8 could go into both, and then you're like 8 times 6a will give me that, and 8 times 7b will give me that, that's great. You just had a shorter ladder, but you see that we still get to the same answer. Okay. Why don't you go ahead and try that last one? This is the one that's really frustrating because you're like, there's not even variables and stuff. Why can't I just add them? Well, they want it rewritten as a different way. Okay. So it's kind of like, how did it start? If this is how it ended, how did it initially start? All right. Well, what can go into 14 and 22? 2 can. And 2 times what is going to give you 14? 7. And 2 times what is going to give you 22? Yep, 11. And bring down that plus sign. Can anything go else to 7 and 11? Nope. So then that's your GCF right there. It goes in front, and then your sum is made up of these two numbers, 7 and 11. So I rewrote this sum as the product of the GCF and some other sum. And then double check it's right. 2 times 7 is that 14. 2 times 11 gives me that 22. Perfect. I know I'm right. And that's all there is to it. Okay, you're going to do amazing.